Hi, in this lecture video, I'll be discussing solution dilutions. And there are two learning objectives in this lecture video. First is for us to recognize what is dilutions, what does it mean? And then second, how to calculate what is the concentration of a diluted solution. So dilution is basically referring to the making of a more diluted solution or a less concentrated solution. Whenever we have a solution, if we would add more water to it, we would then recognize that the solution will become more diluted or less concentrated, right? And so the act of adding more solvent or another liquid into an existing solution would then make that solution right there become more diluted or less concentrated, and then this is then referred to as dilution. So we can see that a stock solution is basically the concentrated or the original solution that you start out with. It can be diluted by simply adding more solvent or another liquid to it, and we can see that will change the concentration of our solution, right? So how do we figure out what would then be the concentration of our diluted solution? Then, fortunately for us, it can actually be figured out very easily by using this very famous equation right here that we call M1V1 equal to M2V2. So what this means is as follows, and this will be one of the very few times that we actually use an equation in chemistry, because normally we will try to solve root problem by using dimensional analysis, but in this particular topic right here, it is easier for us to actually use algebra and using this equation right here. So what is the meaning to this equation right here? M1V1 means the following. M1 means the molarity of the original or the stock solution. And again, stock means the concentrated or the original solution. And V1 here would then be the volume of that stock solution right here. So how much of it do we have in terms of volume? And now, dependent on how much more solvent that we add to it, the volume of the diluted solution would be changed, right? So what is the volume of this diluted solution now? So that we then call V2. So V2 is the diluted volume. How much more water do we add to it? And now what the final volume become? And now M2 would then be the molarity of that diluted solution. So basically M1V1 equal to M2V2. If we were to know three of the variable in this equation right here, we can solve for the fourth variable very easily. And the fourth variable that we normally solve for would then be M2. What is the concentration of the diluted solution? So therefore, in order for us to solve for M2, we need to know M1, V1, and V2. For an example, let's say we have a beaker of an HCl solution. So this is the initial or the stock solution. Initially, we have 5.5 liters of this solution. And let's say the concentration of this solution right here is 11.6 molar. If I were to now add another 5.5 liters of water to this beaker right here, then I will be able to change the volume of this beaker into now 11.0 liter, right? So in this case right here, the water that we added into this solution right here will be additive into my volume because we added water to a water solution. So its volume would be changed, and now the total volume or the final volume would then be 11.0 liter. So we know that doing this would make our stock solution become more diluted. Initially, it was 11.6 molar. What would now be the molarity of this new HCl solution? How do we solve for it? So here, this is the final or the diluted solution. And to figure out what is the molarity of this diluted solution right here, we will then go back to M1V1 equal to M2V2. And in this case right here, we are solving for M2. And mathematically speaking, to solve for M2, we'll have to divide both sides by V2. So therefore, M2 would now equal the following. M1 V1 over V2 would then equal to M2. So that's how we would mathematically solve for M2. And now all we have to do is plug in all of this variable, and we'll be able to solve for what the final concentration will be. So here in this case right here, this M2 will then equal to M1. And in this case, M1 is the stock molarity, which is 11.6 molar. And important, we include that word molar along with it. Multiplied by V1, which is the initial volume of the original solution. And in this case, it was 5.5 liter. That's what we started out with. And now, divided by V2. V2 is the final volume. And in this case, it is 11.0 liter. So we put 11.0 liter on the denominator. And following unit cancellation, we will then see liter cancel with liter. And we will end up with big M, right? And that is the unit of molarity. And when we take 11.6 multiplied by 5.5 divided by 11.0, this then equal to 5.8. And now the unit that left behind will then be M, which is the unit of molarity. So the final concentration of this would then be 5.8 molar. And that makes sense because if we were to now double the volume of this solution, its concentration would become half diluted. So it would be changed from 11.6 to now 5.8 molar. And that is how we would be able to calculate the molarity of a diluted solution. Okay, and so please keep in mind that any time that we have to figure out, we have to ask ourselves, are we diluting the solution here in this case? And it based on the context of the problem that it involved adding more solvent to a original solution, or maybe adding another solution to an already existing solution, then what we are doing is that we are diluting our original solution that we're interested in. And if that, so that is the context of dilution right there. And the minute that we know that this is a dilution problem, we should be thinking of M1V1 and M2V2 immediately to solve for any of the variable that we are being asked for. Now let's now try a few examples right here. So number one, how many milliliter of the commercial HCl, and let's say its concentration 11.6 molar, should be used to prepare a 5.5 liter of a 0.500 molar HCl solution. So this is the stock solution right here. This is a commercial or the stock solution. And we want to prepare a diluted solution of this volume and this concentration. So the question now is, how much volume of the stock solution that we would need to make this diluted solution right here? This is a very, very common kind of types of problem and the types of thing that we would do in a chemistry lab, because we always prepare diluted solution from the stock solution. And now we have to calculate how much volume of the stock solution do we need to use. So this is one of those examples right here. And so here in this case right here, based on the context of this problem, it's very clear that this is a dilution problem, right? And the minute we recognize that this is a dilution problem, we should be thinking of M1V1 equal to M2V2 and start looking for those variables. So M1V1 equal to M2V2. And here in this case right here, it is asking us what is the volume of the stock solution. So in this case right here, it is asking us to solve for what V1 would be. And solving for V1, we would then see that V1 would then equal to M2 multiplied by V2 over M1. So that's how we would solve for V1. And now we need to start looking for this variable right here. So in this case right here, 11.6 M here, this would then be our M1. And this 5.5 liter right here, this would then be our V2. And this 0.500 molar, this would then be our M2. So we have three of the variable already, and we now ask for V1, the last variable. And that's how we would mathematically set this up to solve for it. And now let's plug in all of this variable right here. So M2 here in this case right here is then equal to 0.500 molar, and V2 is then 5.5 liter. And now M2 and M1 would then be 11.6 molar. And following the unit, we can see the unit will get cancelled out. So M here would get cancelled with this M, and the unit they not cancel out would then be liter. So here in this case right here, we'll be having, after we solve this is then equal to 0.237 liter of solution. So that's how much volume of the stock solution that we need to take out. And now we have to convert this into milliliter. So this would then equal to 237 milliliter of solution. So as we set up this equation right here, it's important to recognize the following. When it comes down to the unit of concentration, it has to be molarity. Okay, so then make sure the unit of the concentration is molarity, because this equation right here cannot be applied to all the units of concentration, but only for molarity. As for the volume in this equation right here, the volume can be any unit that we want. The volume can be in liter, can be in milliliter or gallon or whatever is the unit volume. But it's very important that the unit of V1 and V2 would be the same. So it would only, we can use any unit volume if the two unit volume are the same thing. So we have to convert both of them into liter or gallon, do not matter, but make sure they are the same thing. So that way they can cancel out mathematically. And now let's try this example right here. So why don't you take a minute to solve this before we go over the answer together. So here in this problem right here, say a student at 50.0 milliliter of water to a 25 milliliter of a 0.881 molar sodium hydroxide solution to create a diluted solution. So now what is the concentration of this diluted solution right here? And again, when we after we read through this problem right here, we can see, and hopefully you'll be able to recognize that this is in the context of a dilution, right? And the minute we know that this is a dilution problem, we should be thinking of M1V1 equal to M2V2 and start identifying all of our variables. So here in this case right here, this student right here at 50 milliliter of water into this solution of this volume and concentration. So this 25 milliliter right here, this will then be our V1. And then this 0.811 right here, molar, this would then be our M1. And now it's asking us what is the concentration of the diluted solution. So essentially asking us to solve for V2, M2. What is M2? That's what this question is asking for. So now let's identify all of this variable. M1 is then equal to 0.811 molar, and V1 is then equal to 25.0 milliliter. And now as for M2, V2, what is our M2? This is the question that the problem is asking for. And now as for V2, what would then be V2? Now please note that here in this case right here, that V2 is not 50 milliliter of water, okay? But V2 would then equal to what? 75 milliliter of water. And this is something that you have to be very careful to make sure that we get this correct. Because when we take 50 milliliter of water and we add that into a container already having 25 milliliter of solution, its volume will be additive because water is added to water, and this is an aqueous solution. So the volume, the final volume of this dilute solution right here will then be 75 milliliter, not 50 milliliter. So please be aware of it. This would be the most common mistakes that students would make on quizzes and exam. And now in this case right here, we are solving for M2. And M2 would then equal to M1 times V1 over V2. And solving for this, M2 would then equal to 0.881 molar. That M1. And V1 is 25.0 milliliter. It's okay for us to keep V1 in milliliter. We just have to make sure that V2 is also in milliliter as well. And now divide by V2, which is 75 milliliter. And now we will then see the unit milliliter get cancelled out and we'll end up with big M, a unit of molarity. And that's what the question is asking for. So here in this case right here, Mg will then equal to 0.294 molar. So that will be the concentration of the diluted solution.